Hello everyone. Today we are gonna study about semantic web 5th unit. So, what is semantic web applications and enhancing intelligence? That's the title. What is a semantic web? Semantic web is an extension of the traditional web by adding a machine-readable meaning to the data, enabling smart search, automation, and AI-driven reasoning, and it uses orthologies linked data and logic-based knowledge representation to create more intelligent and connected web. They are the key technologies to the semantic web, which are RDF, OWL, SPAQRQL. You can imagine like as a semantic programming and query language, something like that, and the linked data. These are the four which are the used as a key technologies in semantic web. The real life application of semantic web are Google Knowledge Graphs. It's a search enhancement. Google uses semantic web principles to understand query contextually. Instead of just matching the keywords, it understands entities and relationships. Example, search query, who is directed in inception. And semantic response, Christopher Nolan. It's not just listed of a link. We are gonna leave the second question. What are the healthcare orthologies? Semantic web is a medicine helps to diagnose disease like linked symptoms, recommended treatment. Example, semantic web-powered AI can be linked chest pain, heart disease symptom, suggested cardiology. That means if you have a chest pain, it can related to the heart attack, and it shows the recommended cardiologists and any medical related to the chest pain. What are the smart assistants like Alexa, Siri, Google Assistant? Use orthologies and knowledge graphs to interpret the new natural language. Example, user, what is the weather like in Paris? Assistant understands the Paris as a location and fetched the relevant weather data. That means it can understand which place, and according to that place it can retrieve the data related to the time and a specific geographical location, and fetches the what is the weather. You are understanding what I'm saying, right? So the fifth question, e-commerce product recommendation. Semantic web powered communication understand product context. Example, user searches for running shoes, AI understand it intent recommended sports accessories like Amazon or something. It normally uses the web applications. E-commerce means it like where you can sell and purchase. Yeah. Semantic web versus traditional web. There are features: traditional web, semantic web, data representation, understand HTML, and semantic web was structural RDF OWL, search keyword based, meaning based, interpretability, data subs, linked shared data, AI integration, limited AI driven reasoning and automation. So conclusion was semantic web enhances the search, AI and data interoperability. Google, DP-Pad and healthcare, commerce, e-commerce and smart assistants leverage semantic web principles. Technologies like RDF, OWL and SPARQL makes the web smarter, more connected and AI friendly. Semantic web services and intelligent interval web services. So what is semantic web services? Semantic web services combines the semantic services with the semantic web technologies, enabling automation, discovery, composition, execution, and service based on meaning rather than syntax. For meaning, key features of semantic web are machine readable service description, automatic service discovery and composition, intervality area different platforms, enhanced reasoning usage of orthology. The key technology in semantic web services are OWS, Orthology Web Language Services, WSDL, Web Service Description Language Semantic, and SAWSDL, like semantic annotation for the WSDL and XML schema, and SPARQL, UDDI. UIDDI means Universal Description Discovery and Integration, RESTful and SOAP services. Now you learn the technologies, so you can also know the purpose of these technologies. OW purpose is to define the web services with the orthology, and WSDL purpose is enhancing the traditional WSDL with the semantics, and SAWSDL purpose is add semantic annotations to the WSDL, and SPARQL purpose is query linked data for the service discovery, and UDD purpose is register the discovery web services and web services. The restful SOAP services are SOAP means it's not like that. It was yeah, you get it what I mean. Web services architecture. So let's now talk about semantic web services workflow. There are different kind of it. First one was semantic discovery. The traditional web services required exact keyword matching. SWS uses orthology to find services automatically based on meaning. Example, uses search for currency exchange services. Instead of keyword, SWS understand related term like Fox API or money conversation. And second one was service composition, combining multiple web services automatically based on semantic meaning. The travel booking SWS combined with flight booking API, hotel reserving API, and car rental API. Without any manual iteration, the system created end-to-end travel packages. So third one was servicing execution and innovation. Users reasoning and engines to determine which service is to invoke based on context. If a shipping service required a weight in kg but input is a pounds, SWS converts into automatically before calling the API. Here what is SW means? SW means semantic web services. Okay, you get it right. Services exchange execution innovation. Uses reasoning engine to determine which services to invoke based on context. If a shopping service is required, wait is to. Okay, I talked about this, right? Service monitoring adaptation. If a service is down, SWS dynamically switches into alternative examples like a weather API is unavailable. The system automatically calls weather API B. If there is, for example, I am gonna tell you a meaning. If you are gonna search something like a results or something, if it not only uses one API or one web application, it uses multiple web applications or API. Normally the provider who provides for the services can develop multiple web applications or APIs to access data. So if one is not working, the alternative one can be worked. So I'm gonna skip this question describing OWS description of web services. It's a code you can see once, most once. Pause the video. The real life application of semantic web services applications: e-commerce, health, finance, travel, logistics, OT, and smart cities. So for example, e-commerce automatic product price composition. That means as you said previously, you can use the sale and buy product price automatically. Healthcare, the intelligent patient data retrieve diagnosis. If you typed a patient data, it will show the history of the patient data. Like if the has a long history of medical condition, we can access that easily. And finance, currency conversion, stock market, as you know, stock marketing and the application which related to the stock markets. Travel logistic, automated trip planning, that means you can plan trips wherever whenever you want, like with flight or bus or any kind of transport you can think as it. And you can also search hotels in it. Like you basically remember the web apps that make us to travel. And AOT and smart cities, dynamic energy graph management. It manages mostly energy, and it also used for the industrial to get smart cities, something like that. It's high tech city, but it uses energy efficiency by using semantic web. The traditional web services versus semantic web services. It has, I thought we talked about this. It's previously, no. Yeah, you can write the same, the semantic web versus traditional. It's mostly the same. Semantic web in e-commerce and biometrics. Semantic web enhances both e-learning and bioformation by providing structural machine-readable knowledge that enables intelligent search, interpretability, automation, and reasoning. So semantic web in e-learning. Semantic web in e-learning uses orthology and linked data to improve current discovery and personalized learning and AI-driven tutoring. Moves from keyword-based searches to meaning based on content retrieval. Key techniques. OWS. You can remember orthological web language. You can write however you want. Define the language concepts, course, topic, skills. RDF, resource description framework, structures the learning data. And it SPARQL means query education content simultaneously. LOM, learning object metadata, stabilize the metadata from e-data content. Example, you can see the personalized course recommendation or the logical example of OWL. You can see XML code edit, code class RDF ID course, code as RDF ID student, project property RDF enrollment, domain RDF source student, range RDF source course. In the end, we're gonna close the bracket by using object property. It defines student course and enrollment relationship AI based courses recommendation. The real world applications of semantic e-learning applications. Semantic course recommendation. Example is suggest course based on prior knowledge. Applications AI chatbots, tutors, chatbots that understands learning needs. Automated quiz generation, extract the key concepts from study material. Semantic data from learning resources, retrieve the context of relevant articles and videos. Adapt to learning, adjust difficulty based on student performance. Example was IBM Watson Tutor AI uses semantic technology for adaptation learning. The second question was semantic web in bioinformation. The what is semantic bioinformation? Bioinformation deals with biological data, genes, protein, disease, etc. And the semantic web allows machines to link, analysis, and reason over biological data over better drug discovery and diagnosis and research. To give you example, it gives if you adapt your health symptoms, something you have suffering with, it will show the related medications, something like that. Example, drug disease integration of orthology, ORL orthology example. Like we previously thought, you can just change class RDF ID drug, class RDF ID disease, object property RDF traits, trait, it's open the bracket, and domain reference resources drug reference disease, close the bracket with object property. Then allow the reasoning based drug discovery. The real life application of drug discovery is applications. Gene disease relationship discovery. Example, it identifies the genetic factor of behind the disease. Semantic drug discovery finds potential new uses of existing drugs. Medical knowledge graphs. AI based disease diagnosis. Medical literature mining extracts insight from search and papers. The clinical decision supports enhanced AI in healthcare. Example, the Gene Orthology Go project uses semantic technology to clarify gene across the species. Conclusion: Semantic web revolution e-learning with the smart cities, AI tutors, and personalized learning. In bioformation, it accelerates drug discovery, drug research, and AI-driven diagnosis. Technologies like OW, RDF, and SPQR enable structured and intelligent data processing. Before we go to the another topic, I'm gonna tell you something. This is not the official PDF that I made. It is from JNTU R18, from JNTU section, which come from college or official JNTU website. So if you are feeling any problem, it's just I made it for myself to learn and revise. If you want it, but in so many YouTube channels we are not getting semantic web units explanation, so that's why I made for myself. But if you find it helpful, that's what it matters. And I feel happy if you found it helpful. Okay, so let's dive into next topic, that is enterprises application integration, EIA, which is semantic web. With enterprises application integration, enterprises application integration is a process of enabling different enterprises applications like CRM, ERP, HRMS to communicate, share data seamlessly. Traditional EIA challenge: data sales isolated system, difference data from schemes, lacked semantic interoperability. Some teams same different things in different systems, high maintenance cost. How semantic web improves EIA? Technologies like RDF, and its purpose is stabilize the data extend across system. OWL defines the relationship between enterprises and concepts. SPQRL query integration enterprises data. Semantic web or automated data discovery and execution. ESB enterprises based services, service bus, semantic layer, midware for the integration semantic data. Enterprises application integration uses orthology. It is a different topic. Traditional EIA versus semantic EIA. Integration, interoperability, flexibility, data consistency. They are the features. In a traditional EIA, hard-coded API, manual data transformation, rigid expensive update, required consistent synchronization. But in semantic AI, orthology driven mapping, automated using orthologies, adaptive scalable, uses linked data principles. An example of CMR ERR integration with semantic web scenario: a company wants to integrate CMR, customer relationship management, with ERP, enterprise resources planning. Problem: CMR stores customer as a ID, name, email. ERP uses client with client code, full name, contact info, with common formats like integration with error prone. Solution: using URI orthology is to unify the meaning of customer across the system. These are the code of this one. As you can see, you can use class RDF ID customer, class RDF ID client, OWL equivalent class RDF resources is customers. Open the object RDF as mail, domain, RDF resource customer, range, RDF resource, STS string, and object property RDF ID as a contact information, as the domain, client, range, string, and close the bracket. Now system knows the customer, client, and they are the same entity from the CRM ERP can now merge automatically. And I think you can skip to the third question. We are going to directly skip with the what is a knowledge base. It is one of the main important topics and main one. The knowledge base is structured collection of information enables the machines to understand reasons to retrieve the knowledge intelligently. Traditional knowledge based on stores data, the structural data, SQL, semantic knowledge bases enhance the traditional KV by uses orthology to define relationship between concepts, link data across the multiple sources, link data, enabling reasoning, interfering for AI-driven search. Example of knowledge base and description. Let me explain. Google Knowledge Graph, a powered Google search with the entity-based result. DB paired extract structured knowledge from the Wikipedia data, Wikidata. Collaborate knowledge from search data, IBM Watson, and AI-powered knowledge from representation system. If a Microsoft concept graph, AI-driven knowledge from enterprises. What is semantic search? Semantic search improves a traditional keyword-based search by understanding the meaning of semantics and queries or document. Uses machine learning and NLP and knowledge graphs to provide more relevant search and results. Key technologies in semantic search: orthology, technonomies, define, I can pronounce it very well, define relationship between entities, RDF or ORWL, structured and model knowledge, SPARQL, query basis intelligently, natural language processing, understand users intent, vectory employing, RLLMS, AI powered ranking. How semantic search works: traditional versus semantic search. First, features: method matching, query processing, relevance ranking, entity recognition, reasoning. Traditional search, semantic search. In traditional search, exact keyword match, syntax based, string similarly limited, none. Sorry. Concept based, understand, concept aware, AI based intent recognition, identify people, person, and things, and interfere with relationships. For example, on Google's knowledge graph search, traditional search query, Apple CEO matches with the Apple and CEO keywords. Semantic word: ఇప్పుడు Apple CEO recognizes the Apple company and retrieves Tim Cook as the entity. As you can see, the programming in a programming pattern in this for the search and background. I guess so. What are the applications of knowledge base and semantic search in industry? Search engine: Google Knowledge Graph, Bing, and Yahoo. Use case: it runs where you can from access. E-commerce: AI powered product recommendation, Amazon, eBay. Healthcare: critical decision support system, EBM, Watson Health. And customer support, chatbots, AI driven, FAQ, Salesforce. Finance: fraud detection and AI driven financial analysis. Example: Amazon Alexa uses semantic search knowledge graphs for the better voice assistant. Conclusion: knowledge bases power AI driven insight is search engine, chatbox, and recommendation. Semantic search improves query understand, uses orthology, APL, and AI, SPARQL, RDF, and matches learning, enhances enterprise search capabilities. Next, semantic search and semantic engine. What is semantic search? Semantic search improves traditional learning by understanding the context, syntax, and relationship between words and rather than matching keywords, and uses NLP, natural language processing, knowledge graphs, and AI to deliver more relevant results. How semantic search works. Now we are going to learn about web search agents, intelligent information retrieval. What is a web search agent? Web search agent, also intelligent agents, are search bots or software programming, automated web searching, filter information, deliver relevant results based on preference. They crawl, retrieve, and analyze the rank data from the web using AI and NLP and semantic technology. Types of web services, web search agents. Type: web crawler, meta search agent, personalized search agent, personalized search agent, semantic search agent, AI powered chatbot. Description: as you can see, automatically browsed web and index pages for search, aggregates the results from multiple engines, search engines, adapt search result based on user preferences, personalized. And semantic search agent understands the meaning context of relationship. AI powered chatbots provide answers from database knowledge or graphs. Google bot, Bing bot, Dogpile, Metacrawler. Examples, and last one was ChatGPT, AI powered chatbox. Okay, and semantic search agent, IBM Watson. So, how web-based search works: crawling, indexing, query processing, ranking, filtering, and personalized AI. You can search, see the others. What are the example? Traditional search, intelligent search agent understands the context, analysis, and intent, finds the exact keyword. Like traditional search, it always uses exact keyword, but intelligent AI search agent understands the context, analysis, and like a person or a entity, something like that. The key technologies behind the search agents: web crawling, scraping, automated data collection, NLP, machine learning, understand user query, knowledge graph, orthology, improve semantic understanding, SPA, RQL, RDF, query linked efficiently, vector search AI model like BERT, GPT, World to Vec, similar content. Find the similar content. Okay. Example: query best laptop of gaming. Traditional search matches best laptop and gaming. Intelligent search understands the intent of the recommendation, performs high performance gaming laptops. Applications of search agents: industries, e-commerce, personalized product recommendations, healthcare. Like you learned in previous one, it shows a more profound information in e-commerce, healthcare, finance, and legal customer supports. Example: IBM Watson Discovery, AI powered search analysis, enter the document and extract insights. And to be put simply, web search agents are simply like the AI powered search agents, which are smart and do the more efficient work compared to the traditional search. Yeah. Conclusion: web services agent automatic the intelligent search and information retrieval. AI, NLP, and knowledge graphs are enabled smarter, personalized results used in e-commerce, healthcare, and legal, and AI powered search assistants. The semantic methods enhancing the searching and knowledge representation. What is semantic methods? Semantic methods are the techniques to enhance the information retrieval, data processing, and AI understanding by focusing on meaning, context, and relationship rather than the keywords. These methods are widely used in semantic search, natural language processing, NLP, artificial intelligence, AI, and semantic web. The key semantic method: orthology and knowledge graphs. Define the relationship between entities, uses RTF and ORWL. Example: Google Knowledge leads helps to browse knowledge Natural language processing understands the human language in search queries and text, include the tokenization, limitation, entity recognition, and sentimental analysis. Example: AI chat like GPT process chat simultaneously. Semantic search reasoning uses meaning based on retrieval instead of keyword matching. Implement interface rules to reduce new facts. Help the Google search but model improves query understanding. Linked data connects structural data across the multiple sources. Uses SPQL query to retrieve the semantic knowledge. Example: Wikipedia uses RDF triple to linked facts of the Wikipedia. Vector enables the deep learning convert the word sentence into mathematical vectors for the similarity compensation. Uses models like BERT, World to Vec, GPT, and transformation based on architectures. Example: Semantic similarly detections to the AI powered engine. Semantic method versus traditional methods. We previously thought the traditional methods for this limited most of the cases, like context understanding, entity recognition, and reasoning. It has no reason because it is a traditional method with no reasoning. Data representation, text based, it represents the data with the text. Query matching, exact keywords, but in semantic web the query matching means meaning based retrieval, and context understand AI driven intent recognition identify the concept relationship. In reasoning uses interface and orthology, like traditional method which don't have the reasoning, but semantic web has the data representation, graph based AI powered. Traditional search, fastest land animal matches pages with the faster an animal. The semantic search, fastest land animal, recognize the cheetah as the correct entity. Applications of semantic methods: search engines, Google, Bing, Yahoo, and semantic search. AI powered assistants, Alexa, Siri, as how many AI chatbots are there? E-commerce, Amazon is recommended. Healthcare is AI driven diagnosis and clinical search. Finance, fraud detection, sentimental analysis. Example: Amazon search engine understands the synopsis context, offers better product recommendation. Conclusion: semantic method improve AI search, NLP, and knowledge representation. Technologies like NLP, orthologies, and vector now improved driven meaning based on retrieval. Used in search engine, chatbots, finance, and healthcare and AI applications. I am not gonna stretch this answer very much longer, so I'm just simplify the last answer simply. Latent semantic search, ape, tap and swiggle. I can't pronounce it correctly. Latent semantic search. Latent semantic search improves traditional search by analyzing relationship between words and their meaning using latent semantic search (ALCA). It helps to retrieve contextual data results even exact keywords are not present in query. How it works: uses singular value decomposition as like SVD to reduce dimension into text. Find a latent, hidden relationship between words. Improve the synopsis, recognizes and context-based search. Example: traditional search query based best phone for the photography matches exact keywords, but latent semantic web search understand the camera quality, phone camera, and low lighting photography. To be tell you that latent means very deep and very strong, powerful. The meaning of the word is use cases: AI-powered searches, Google Bing, recommendation system, Netflix and Amazon, document retrieval, legal health data, and enterprise search. The TAP project. TAP is a semantic web project that creates a distribution decentralized knowledge base. It is entirely affordable linked data and knowledge representation features. Uses RDF, resource description framework for the structural data. Connect information from the multiple online sources. Enables a semantic search and reasoning data set. Example: it helps to early semantic search by linking concepts like movies, books and people inspired by modern knowledge graphs, Google, Wikipedia, Wikidata, and DBpedia. I think it's something related to the knowledge retrieval like Wikipedia, etc. And the last one was Swaggle. Swaggle was a semantic web search engine developed by the University of Maryland in the index RDF documents, orthology, and metadata. How Swaggy worked? Crawled and indexed semantic web documents, allowed SPQRL query for retrieval structural knowledge, helped researchers discover RDF and OWL orthologies. A user searches from orthology for medical diseases could find a relevant RDF in oral dataset. It helps to semantic web to integration in modern tools like knowledge graphs. And I can't go more deeply because its screen recording has its limits. So I slowly scroll down. You can see that. It will be no issue if you write the what I explained. It's not good to tell I am explaining. I first time seeing this PDF and I directly just reading it mindlessly, but it's better than doing nothing. So I'm just gonna upload it to YouTube so you can understand, if I hope so. It's better I'm gonna turn this video into completely private after exams are over, so just learn what you can. Thank you. If you are kind enough, please subscribe. I will not mind if you don't, but do it please.